Are you ready to up the ante? Here we go. Okay, here we go. Here's our next video. Our next video is, again, multiplication properties of exponents. Here is our second property. Our second property of our PPP properties. This is the power of a power property. Okay, lots of P's. Told you. Peter Pepper picked a peck of pickled peppers. It's fun. All right, so in this property, we are sort of solidifying what we're going to be taking what we learned in the last lesson and applying it to a bigger concept this time. This time, this concept is dealing with some multiplication of powers. So if an exponent is raised to another exponent, another power, it equals that base raised to the product, the multiplication of the exponents. So this wasn't written very well. I'm sure I missed a couple of words. Here is our example. 6 raised to the second power raised to the fourth power. That essentially equals 6 to the 8th power. Now let's understand why exactly that is happening. Again, I am highly suggesting to you showing expanded form of all of this. So 6 to the second power raised to the fourth power is essentially us saying 6 squared times 6 squared times 6 squared times 6 squared, right? 6 squared 4 times. Now, we already know from the previous lesson that if we have a base over and over and over raised to an exponent and they're it's a product of all of those, we can add our exponents. So technically, we have 6 times 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 6. Which is 8 sixes. 2 plus 2 plus 2 plus 2 equals 8. Picking up what I'm putting down? So I am using the previous property that we just learned and applying it to this concept here, so it proves our understanding that 6 squared raised to the fourth power equals 6 to the 8th power. So I can essentially just say simply 6 raised to the second times 4, or 6 to the 8th. Okay, so now let's apply this to a few problems. Let's look at this in action. Here we go. So we have 3 to the fourth power raised to the fifth. Just like in the last problem, I highly, highly, highly encourage you to rewrite this in expanded form. So that means that I'm going to expand out this for like most outermost exponent. So I would rewrite this as 3 to the fourth times 3 to the fourth times 3 to the fourth times 3 to the fourth, and one more time times 3 to the fourth. Just like last time, this is building on the previous exponent property that we did. 3 to the fourth, 3 to the fourth, 3 to the fourth, all of those threes are all the same base. Therefore, I can add my exponents. So 4 plus 4 plus 4 plus 4, actually 5 times, sorry. 3 raised to the 4 plus 4 plus 4 plus 4 plus 4 equals 3 raised to the 20th, or 3 raised to the 4 times 5, or 4 times 5 equals 20. So 3 to the 20th. Awesome. Super exciting. Let's look at 2 more. 2 more. This time, 6 to the 0, that's not a 0, 6 to the 0 raised to the third power. Cool? So let's expand this out. Everything inside of these parentheses would be the thing that I'm multiplying by itself 3 times. So I would be writing this as 6 to the 0 times 6 to the 0 times 6 to the 0. Now technically, 0 plus 0 plus 0 is 0. So 6 to the 0 would be my final answer, or 6 plus 0 plus 0 plus 0, or 6 to the 0 is my final answer. Written in exponent form. Now I highly suggest you actually do the math on this one because the exponent is not too big. Like 3 to the 20th, I don't ever want you to figure that out. That's an insane number. It's huge. It's literally probably bigger than trillions. I don't want you to figure that out. But 6 to the 0, we can rewrite that as 1 because everything raised to the 0 power is 1. That's simple. We can handle that. What we could also do is instead of expanding it out, we could have used this property, which essentially tells us that these exponents will multiply each other. 0 times 3 is 0, which is 1. 6 raised to the 0 power is 1. Cool? Last one. Going to get nice and tricky on us. This is going to have multiple properties that we're building on, more than the last two. A to the 3rd power raised to the 4th times a to the negative 2nd power raised to the negative 3rd power. I know, multiple negatives in the exponents. What's nice is we don't have to worry about them. In this situation, we have a negative times a negative, right? Because this property is so great that I now understand that if I were to expand this out, this is a to the 3rd times a to the 3rd times a to the 3rd times a to the 3rd, so 3 times 3, or 3 plus 3 plus 3 plus 3 plus 3 equals 4, or 12. So I could say 3 times 4 equals 12. And this one over here, this is a to the negative 2nd power times a to the negative 2nd power times a to the negative 2nd power, but it's raised to the negative 3rd power. So essentially, this is where things get tricky for this part. If I wanted to write this out in expanded notation, to show that it's negative 3rd power, I am going to be writing this as 1 over a to the negative 2nd power times a to the negative 2nd power times a to the negative 2nd power. Notice, this negative 2 did not disappear. Why? Because I'm just dealing with this negative on the 3. To expand this out, everything else in here gets preserved because this is all repeated over and over. So that negative is still there. Now, how do I deal with that negative? I essentially have a fraction within a fraction, so I'd have to deal with that. How do you deal with a fraction with a fraction? You're essentially dealing with multiplying by the reciprocal or like the opposite. So might as well just embrace this power of a power property and say negative 2 times negative 3 equals a positive 6. So I have, for this first part of this exponent, a to the 12th times this second part of the exponent, a to the 6th, which now allows me to actually fully do the previous property, which tells me that I can add my exponents. A raised to the 12th power times a raised to the 6th power. I'm going to add these two exponents together. So I get a to the 18th for my final answer. I know all of this is already starting to get really, really muddled, and you are going to eventually get very, very fluent at this. But right now it's going to hurt, and you're going to make some mistakes, and that's okay. But it's going to be really important that you look at my answer keys when you do your must-do practice problems and not skip the must-do practice problems. If you do not do the practice for this, it's going to be incredibly apparent. And this concept builds on itself even more in the next lesson. And then in the next, well, first, it's going to build even more in the next video. But then after that, it's going to build even more on the next lesson. And then I'll build even more in the next lesson and even more in the next one. So please do the practice problems. All right, one more video after this, and then really do the must-do practice problems and do the exit pass. All right, I'll be back in just a moment. Bye.